So you receive an invitation in the mail to your friend's wedding. You see that you're allowed to bring a +1, but you don't have anybody. Then you get an idea. That new guy or girl at the office is pretty cute. They could be your +1. But you have to catch their eye first. So you work out a little, start dressing nice, and go to the beach to get a tan. You arrive at the beach and the sun is shining, not a cloud in sight. It's a perfect day for a perfect tan. You spread out your towel and let the sun do its work. But what is its work? Well, to get tan, you need to produce more melanin in your skin. To produce more melanin, your skin needs to be exposed to ultraviolet radiation, but not too much or else you'll get sunburned. To know what that right amount is, you're going to have to learn a little chemistry. The sun emits radiation of all wavelengths, from low-energy radio waves to the visible light we see, to higher-energy ultraviolet waves and others. You care about UV radiation right now because you're trying to get that perfect tan. But remember, you need just enough to get tan, but not so much that you get a sunburn and damage your skin. So how do you get the right amount? The answer has to do with the beautiful atmosphere above you at that beach. If there were no atmosphere around Earth, well, we wouldn't be here in the first place. But if there were no atmosphere to protect you from UV rays, you would sunburn, and worse, within seconds or minutes of being outside. It's a good thing you have the ozone layer. The ozone layer is a region in the stratosphere responsible for absorbing a large amount of UV radiation from the sun. How does this happen? There's a delicate balance in place called the ozone-oxygen cycle, which makes sure an acceptable amount of UV light passes through the atmosphere. There are 3 parts to this cycle. First, initiation. An oxygen molecule, O2, is split into 2 oxygen atoms by high-energy UV light. Those lone oxygen atoms can combine with other O2 molecules to form ozone, O3. Next, propagation. Slightly lower energy UV radiation breaks ozone into O2 and a lone oxygen atom, which can then react with another molecule of O2 to reform ozone, releasing heat in the process. This is the key step in the process because it traps UV light, converts it to heat, and maintains a constant amount of ozone in the atmosphere. Finally, termination. A lone oxygen atom can react with ozone or another oxygen atom to reform oxygen gas, O2. Each step in the cycle persists in harmony, allowing a constant amount of UV light to reach the ground. That is, until humans came along. Humans invented compounds called chlorofluorocarbons, or CFCs, because they work very well as refrigerants and aerosols. However, what we didn't take into account was that they interrupt this ozone-oxygen cycle in a very profound way. It turns out that ultraviolet light breaks down not only O2, but also CFCs, providing a whole new source of free radicals that react with ozone. The cycle is no longer balanced, and instead, the ozone layer depletes, leaving the Earth with more and more harmful UV rays, and leaving you with a sunburn. Thankfully, some scientists started to notice this and published their findings, prompting the Montreal Protocol to be signed in 1987. Every country in the world agreed to phase out all CFCs and other ozone-depleting substances, a great feat in international diplomacy. Thanks to the effects of the Montreal Protocol, the ozone layer, though still damaged, has recovered significantly and should continue to heal over the next century. Returning the atmosphere to proper ozone levels will help you get that perfect tan so you can get that perfect date to make the most of that wedding invitation. That is why you should care about the ozone layer. If you enjoyed this video or learned something about organic chemistry, remember to like and subscribe to my channel. Also, please consider donating to my Patreon page, linked in the description, for access to even more interesting material like this to help you learn. Thanks for watching.